So, Janta, welcome once again to my channel Puzzle Pandit. And today we are going to do this puzzle named Spotlight. This is by Sartor. This is under 3-star difficulty puzzle. And from the comments, it seems that the breaking is difficult. Let's see how much we can do. The rules are really simple. Standard Sudoku rules, normal Sudoku rules apply. That is each row, this is each row, each column, and in each 3 by 3 box contains the rules 1 to 9 only once without any repetitions. And then digits in cages cannot repeat. Right? So we see these cages, these are dashed lines. So the digits there should not repeat. So now by normal Sudoku rules, digits here will not repeat definitely. Digits here also will not repeat. But digits here can repeat. Right? I mean this and this could be same by normal Sudoku rules. But because these are in cages, the digits will not be same. So all these digits should be different. All these digits should be different. So that's what this means. And must sum to the small clue in the corner of a cage, right? So again, it should not only repeat, but whatever digits we are going to put it, the sum of them should be 12. So similarly here, the sum of them should be 18. Here, the sum of them should be 32. So to simplify this puzzle, what you can do is, if you are watching this, there is in advance, if you are using Sudoku pad, I think you will be using Sudoku pad only. So there is killer calculator. You can on that, but I am not going to on that. So normally I keep it on, but today I think let's try it without this calculator, cage calculator. It is called. Wait, no, what is that? It is in advanced and killer calculator. It is called as killer calculator. So I am keeping it off, and without keeping it off, let's see how much we can do. So let's start this puzzle. Uh, so initially I can see this box, right, straight away. Now, the sum of all the digits in this box must be 45 because we know that at the end, this box will contain the digits 1 to 9 only once. And sum of all those digits, if you do 1 plus 2 plus 3 plus 4, that will come to 9. So this is called as triangular digit, triangular number. So triangular number for any number is if you sum all the numbers from 1 up to that number. So triangular number for 5 will be 1 plus 2 plus 3 plus 4 plus 5, which is 15. So this is triangular number for 9 and which is 45. So if you do all plus 1 plus 2 plus 3 plus 4 up to 9, you will get the number 45. So this sum is definitely 45. We know that the sum of all these digits. Now let's do the sum of these digits, right? So this will come to as a 9 plus 9, 18, 18 plus 10, 28. So sum of all these digits, right, which are in green is 28. So what is the sum of these two digits? These two digits which are not green, okay, that must be now 45 minus 28. And if you do that sum, that will come as 17. And there is only one way to get 17 in two digits which are looking at each other, and that is 8 and 9. So these digits are definitely 8 and 9. That's it, I think. I don't see anything we can do here. Yep. So 10, correct. I don't see exactly how to do this, but 10, there are 4 ways to get the 10, right? One of these is 2, 3, 5, which is without using 1. The other 3 ways are using 1, which is either 1, 2, 7, 1, 3, 6, or 1, 4, 5. 9 in 2 digits you can get in 4 ways, out of which 1 8 is gone out of question because 8 is already here. So all these must be coupled between 2, 7, 3, 6, or 4, 5. So these are tightly covered, right? We can say that. Now, if that's 2, 3, 5, right? I think that will be, let's try this. If this is 2, 3, 5, right? This is not possible, right? Because then this cannot be 2, 7, this cannot be 3, 6, or 4, 5. So that cannot be 2, 3, 5 because otherwise 9 is not possible. You cannot get this 2, 9. Right. So 2, 3, 5 is definitely not possible. That means 1 is somewhere definitely there. No, that's it. I was thinking is 1, 4, 5 possible? No, something like that. 1, 4, 5 will give a lot of freedom for here, I think. Because Yeah, I mean, yeah, all the days will give, right? Because now one is there, so the other sum sums to nine. So yeah, so there are now three pairs of nine here. Those could be anything. Those could be anything. uh, so I don't think we can do now anything more here. What's it? 22 is very high, right? Definitely 9 must be there. That is what I know. Because if you do not have 9, right, in three digits, in three cells, the maximum you can have is 876. Sorry, which goes up to 21. So 9 must be here. Again, 12, 4, we know that 1, 2, both 1, 2 must be present here. If you do not have any one of these, 4 is not possible. I mean, just try that, right? Without 2, 1, 3, 4, 5. 3, 4, 5 itself is 12. Just give me 1 minute. Yeah. So 3, 4, 5 itself is 12. We just add 1 into it. That will become 34. That is out of line. So both 1 and 2 must be there. Uh, both these are very high, right? I mean, 24 into, if you do that on an average, it is 6. I mean, there are a lot of options to get this, even 32 in 5. There may be options, lot of options to get this. 18 may be less. Yes, look, 9 is here, right? So, uh, if 18 has 9, right? So, then you have now 4 digits to sum to 9. Yeah, but that's not possible, right? Because minimum 4 digits you can have is 1, 2, 3, 4, and that's itself sum to 10, right? 1 plus 2 plus 3 plus 4, if you do, that will sum to 10. So if 9 is here in this case, minimum it will be 90. So definitely 9 is not here. And now if you look at this box, right? 9 is not here. 9 is not here because of this. 9 has to be here. That doesn't do anything here. Neither it do anything here. 9 could be in here. 12 will not definitely have 8 or 9, right? Because even 7 it cannot have, right? Yes, 7, 8, 9. 12 definitely do not have 7, 8, 9. Because imagine if it has 7, right? Then the remaining 3 digits must come to 5, and that is not possible because again, the minimum 3 digits we have 1, 2, 3, which sums to 6. So definitely 7, 8, 9 are out of questions in this box. uh, Again, 18 should uh, 5 digits, right? If you do 1, 2, 3, 4, 5, that is 15. So if you remove 1 from there, that will go to 6 here. So definitely 1 is here. Because if you, yeah, simple way to do that, remove 1, now you get 2, 3, 4, 5, 6, right? If you sum those digits, you will get 20 because again, the triangular number for 6 is 21. And if you remove 1, you get 20. So 1 must be there. What about 2? So if you do 3, 4, so 2 is not there again, it will be 1, 3, 4, 5, 6. And if you sum all these numbers, you will get 21 minus 19. Yeah, so 2 is also there because otherwise, if you take the least numbers without 2, you get 19, which is again get redundant. Yeah, so these box, right, whatever this virtual box, which is getting from 12 and 18, they must have two ones and twos between them. Something similar, maybe we can get here with 8 and 9. So 32, if 9 is not there, I think that's fine, right? 87654. And triangular number for 8 is 36. So 87654. You remove 6 from there. So 36 minus 6, 30. Yeah, so 9 must be here definitely. 9 must be here definitely. Because if 9 is not there, again the 5 digits, 87654, those sums to 30. And then I think 8 should also be must be there, right? I mean, it's similar to here. If 8 is not there, then 97654 over 7, it is 28. 28 minus 6, 22. 22 plus 9, 31, right? 8 must also be there. I think it's similar to this. So 8, 9 must be here. What about 24? If 9 is not there, the 24. So 24 we know that, right? I mean the last 4 digits, right? 6, 7, 8, 9. They all sum to 30. So uh, so if you do not have 6, right? I mean if you do not have 9, you will get 5, 6, 7, 8. So remove 9 from 30, which is 21, and then add, which is 25. So that's fine, right? I mean, if 9 is not there in 24, I think that's fine because you get 5, 6, 7, 8. 8 is 36. 36 minus 10, 26. So yeah, so you don't need to have 9 here. So it's not exactly like this because here 12 must have 1 or 2, 1 and 2 both. But here 24, 9 itself is not. Uh, so we are stuck, I think. All these are a lot of options, right? 12, 18, 13. Because if you do, right, 12 divided by 3, this is 3 cell, it's 4, right? The average itself is 4, so it will have many options. Even 18, right, the average itself is 3. So, uh, and why I'm saying 3 is that because 5 is normally uh, kind of, the average kid, the average number, not average kid, the average number. So anything near to 5, right, 4.5 or 5.5, 6.5, some, or up to 6, right, they will have many options. There is no point in that. Right, so maybe now we have to try some set theory here. Definitely. So if you look at this box, right, the sum of this is 24 plus 32, right, which is 56, isn't it? And if you look at this box, which is 30, yeah, because see clearly these are two boxes, right, which are here. So I think there could be something going on here, which is 30 and 56. And the difference is 26. 26 is a quite good difference, right? So let's try some set theory here. Let's remove this color here. Uh, so what can you do? Yeah, we already have colored this set. So let's continue with that. So let's say these are 3 sets that I have selected. Okay, so these are, you can consider these as a 3 sets from 1 to 9 digits. So 3 sets of 1 to 9 digits. So this contains exactly 3 ones, 3 twos, 3 threes up to 9. And then similarly, I'll select another set which is 3 sets of 1 to 9 digits, which is green. Now if I remove this, right, because now, so currently both these sets contain the same digits, uh, which are 3 sets of 9 digits exactly. So now if I remove one digit from each of those, which is the same digit. So let's say if I remove 1 from both the digits, both the sets, right, only one from both, we can clearly see that those sets will not change. So till now, even if I remove this, both the pink and green will be same. So similarly, if I remove this one, again the same digit from both the sets, it will be same. So if I remove again this, it will be same. So if I remove kind of one by one everything, so we can still say that all these are same. Now let's remove this, right, from pink. So now this is 56, right? So what currently we can say that the green is 56 more than pink, right? Because we have removed 56 from here. And now let's remove this 30 from here. And now green was 56 more than that, but now we remove 30 from green. So now we can say that green is 26 more than pink, right? Uh, So green is 26 more, right? So we have removed much bigger chunk from pink, right? So clearly pink is less now. Um, even if I put, and the difference is 20 there, right? Because the difference here, and I don't think anything else we can remove from green or pink. So um, now green is more, right? So if I put 1, 2, 3 here and 7, 8, 9 here, because these are the least 3 digits I can put here, and these are the biggest 3 digits I can put here. Um, now this is nowhere near, right? Because now these sum to 7, 8, 9. I mean, one of these row 7, 8, 9 sums to 24. So these three sums to 72. 1, 2, 3 sums to 6. So all the pink sums to 18, and 72 minus 18. I don't think it's anywhere near to 26. 72 minus 18. It's, I think, 54. No, it's nowhere near to 26. So this doesn't help. Uh, so normally that's we do, right, in set theory. We try to eliminate as much as possible, and then whatever is the remaining, right, we try to optimize it, the digits. Maybe there could be some kind of, sometimes you get not exactly a match, but some kind of freedom of movement. What do you call? Uh, so freedom of digits, right? I mean something. I mean imagine um, if this difference could have been mm, something like 70, right? 50, right? So now we have degrees of freedom. So you have 2 degrees of freedom, right? Because this difference is 52, and if the difference was 50, actually we got, then we could have 2 degrees of freedom. So these digits could be between 5, 6, 7, 8, 9, and these could be 1, 2, 3, 4, 5. But with the difference of only 26, I don't think there is any degrees of freedom at all here. I mean, these could be anything, and these could be anything. Mm. Yeah, but definitely whatever is in green is 26 more than pink. That is definitely sure by me. So yeah, so that did not go anywhere. Maybe other way around. So by other way, what I mean is maybe this way around, right? This is also way, right? It is still also selecting all this pink and all this green, right? Yeah, so same deal. I have selected 3 columns. That means 3 sets of 1 to 9, and then 3 rows. That is another 3 sets of 1 to 9. And now I'm removing all the common digits between them one by one. So now we both are same, right? Both these green and pink are still same. Now I'm removing 56, right, from pink. So now we know that green is 56 more than pink. Now I'm removing 30 from green. Uh, now green is still 26 more than pink. But now we got something more, right? So now we can have this 22 and 12. So that's the difference of 10, right? 22 minus 12 is 10. So currently we already have the difference of 26, where green is more. Sorry, where pink is more, right? Pink is where green is more. I'm sorry, where green is more, right? Because we have removed a bigger chunk from pink. So currently green is more, and now we are again, uh, you know, making 22 minus 10, and 22 is bigger chunk. So we are taking 10 bigger chunk from the pink. So overall now we have made green 36 more than pink, right? Because it's 56 minus 30, which was 26, and then again bigger chunk of 10. So 26 plus 10. So currently it is now green is 36 more than pink. So now let's try 1, 2, 3, 7, 8, 9. Right? So now green is, we know more, so we are trying the biggest that we have, which is 7, 8, 9, and this is the least. So we are trying this. What do we have now? So 6 plus 6, 12, and this is 48, and 48 minus 12 is 36, right? So that is correct. So now we have So this is now the optimum position, optimum numbers that we have put in those cells, because along with maths, those are the only working sets. If I just remove any one of these, right, the difference will be definitely less than 36. And if I increase any of this, the difference will be 36. So yeah, so those are the definitely the digits in these positions. And I think that's what the break-in is. And yeah, I can see how why this is difficult for people, because this also involves the maths. But again, luckily, we got the exact difference of 36 and not any degrees of freedom. So now we'll have to go ahead from here. So I'm removing all these things. I don't think now we will need these things, this kind of things. 9 is fine. No, let's remove this also, because this is across the region, right? Across the region creates problem. Uh, okay. So we got at least this thing, 789, 789. This is 1, 2, 3, 1, 2, 3. Right. So the first thing I notice is that these four corners, right, which are looking at all 1, 2, 3. Okay, let me color those. Maybe we'll remove that color later. Maybe not this. Sorry, my bad. Which color? Yeah, let's yellow color, right? All these four now they all are looking at 1, 2, 3, and 7, 8, 9. Right. So what are the remaining digits in this? Those must be 4, 5, 6. 4, 5, 6. Uh, Okay, right. So what none of those is one, right? We figure out that this there must be one here. It cannot be 2, 3, 5, because 9 was not possible, right? If you have 2, 3, 5 here. So now where is one? One is not here. Okay, one is gone from here, because 1, 2, 3. This is triplet, and triplet means these three digits only will occur here. You cannot have 1, 2, 3 in any of these, right? This anyway is not 4, 5, 6, but you cannot have 1, 2, 3 digits in anywhere here in this column except this, right? So none of this is 1, 2, 3. That means none of this is 1, but we must have 1 here, so that has to be 1. Uh, right. So yeah, how do we do? So this is only 4, 5, 4, 5, and 1 possible. Why 6 is not possible? Because if 6 is here, right? 1, 6, 6 plus 1, 7. This must be 3, right? To get the 10. But 3 is not here. So 6 is definitely not here. And with 4, 5, this has to be 4, 5. So we got this 4, 5, 4, 5, 1, 4, 5. We got this one. 4, 5, 4, 5, right? Again, this couple 4, 5 only possible here. That can be 4, 5. That has to be 6. So now we can remove 6 from here. Uh, yeah, now we got 6, 4, 5, right? One of the couple from here. So the other will be 2, 3, sorry, 2, 7, and 3, 6. Um, See, that's not 2, 3, or 6. So that's only 7 possible here by Sudoku, and that's 2. That means that's not 2, 7, that's 3, 6. What else can we have? This 12 kg, right? Yeah, just take the minimum digit, right, from each of these. So we'll take 1 from here, we'll take 4 from here, and we'll take 7 from here. And what is the total? That's 12, right? 1 plus 4 is 5, 5 plus 7, 12. So that's the only possible way. Otherwise, even if you take 2 from here, the sum will not work. So that's the only possible way, 1, 4, and 7. So now we can remove 1 from here. We can remove 1 from here, right? So now that's 1 because of this one. 4, 5, 6. So we can remove 4 from here. 7. We can remove 7 from here. So 7 has to be here, right? Because 7 is not there, and this is 7, 9. So 7 has to be there. We know that 9 has to be there because 9 was here, right? Because 9 was here. 9 cannot be here. 9 cannot be here. 9 has to be here. So this is 7 and here. 8 is not here. And that means that has to be 8. uh, 7 is not here, right? 8, 9, 8, 9. Now we can pencil mark. 9 is always here. Uh, Now we got 4, 7 here, right? So what about 18? 18, can it have 9? So if I have 9, the raised two digits will be 9. You cannot have 1 8, you cannot have 4 5, you cannot have 7 3. You can have 3 6 8. So 3 6 9 is possible here. But if you do not have 9, you will have 8. The raised two digits will be 10. So you cannot have 2 8, you cannot have 1 9, you cannot have 4 6, you cannot have 3 7, right? So 8 is definitely not possible. Uh, so 3 6 9 is the only possibility, right? Because with 8, you cannot have any combination here, because 8 means the raised two digits must be 10. But because all these digits are gone from each of the pair, which can put 10, you cannot have 8 here. And if you do not have 8 here, with 6, 5, and 3, 18 is not possible. 6 and 5, 11, 11 plus 3, 14, right? Which are the only next available digit except 9 and 8. So if this do not have 9 and 8, the other available digits are 6, 5, and 3 because of 147, and 653 is definitely not written. So this is the only possibility, which is 369. So all this is 369, 369. Yeah, look at that. 6 is not possible and 9 is not possible. Again, this is couple. 8 9 is here. So you cannot have 8 and 9 in anywhere. So that's not 9. And by Sudoku, that's not 6. So that's 3. None of that's 3. 3 9 6 9 6 9. Now by Sudoku, we know that 6 is somewhere here. 9 is somewhere here. Yeah, so now look, 32 kh, we have figured out, right? 32 must have 9 and 8, out of which we know 9 is one of these. So 9 cannot be here. 24 could have 9, so we don't know. But by Sudoku, now 6 is somewhere here. 9 is somewhere here. Where is 8 now? Here. 8 is not here. None of that's it. That has to be it. So now 32 also got 8. Okay. Yeah, by Sudoku, now 8 is here, right? In this box. That's the only place for 8 in this column. 2, 9. What is, oh, these two digits, right? Must be 2 5 just by Sudoku. I'm just looking at this 8 and this, the new digits has made any significant contribution in terms of Sudoku by reducing the number. Sorry. No, I don't think so. Yeah, but I can see that now these 3 and 3 is giving 3 here. And now I think that is significant for this 12, because 12, now imagine 3 is there, right? So what are the other 3 digits in 3? Those should sum to 9. And without 3, the only possibility is 1 to 6. Because 9, now you have to make 9 using 3 digits without 3. The only possibility is 1 to 6, because if you cannot use 3, so 1 to 6 is possibility. If you do not use 3, 1 4, right? 1 4, next will be 5, which is already larger than 9. So this is, so 5 is not possible here. So this has to be 2, because now this is 1 2 3 6, 1 2 3 6, right? So 5 is not possible. So that's 2, that's 5. You can remove 2 from every of these, because cages cannot repeat the number 6. This is not 6. So 6 must be here along with 3, right? Again 3 is here, so 3 is not here, so that's 1. And we can remove 1 from here, so that's 3 6. 3 6 3 6, right? Again this couple, looking at that, so that has to be 5. That 5 gives 4 here, that gives 5 here. Does that do anything more? No, I don't think so. This is 3 6 3 6 couple again. This 5 now, right? This 13 and this 5. So now these should sum to 8. What are the possibility? Let's just put the possibility either 1 7 or 2 6, because 3 5 is not possible because of this 5. Oh, and that's none of 2 7 and 6, right? That's none of 2 6 7. So that's 1, and that means to complete this 8, this must be 7. So 7 is now one of these, right? Just by Sudoku. These two digits, right? Which is 1 2 3 4 4 and 9. isn't it? Uh, that's correct. These three digits now 1, 2, 3, 4, 5, 6, 7, isn't it? 5, 6, 7 will give 9 here, right? Because you cannot have now 6 here, so that's 9. That's 6. Mm, these three digits, right? 1, 2, 4. That's not 2, that's not 1. That's not 1 and 4, so that's 2. That's not 2. So this is 1, 4 pair. Now these two digits, right? 1, 2, 3, 4, 5, 6, 7, and 9. Now 7 looking at that, that gives 9, that gives 7. 9 gives 8 here, that gives 9 here. We know that 9 is not here. We know that 9 is already here. Yes. 8 could be there, right? In the 18th case, that's the problem because 8 will, the rest of the digits will be 1, 2, 3. So that's not a big problem. 22. Now look at this. See, 22 consists of all the high digits. Uh, so 9 is definitely there. The rest two digits must sum to 13, which is either 5, 8 or 6, 7 because 9 is already there. So 4, 9 cannot be. So it's 9 with either 5, 8 or 6, 7. So now look at this digit. So this is, I mean, 22, everything is exactly consist of 5, 8, 6, 7, 5, 6, 7, 8, 9, those high digits. But all 5, 7, 8 is gone there, right? Along with 9. So the only possibility is 6 here. And with 6, the only possibility is now 5, 9 here, right? Sorry, not 5, 9, 7, 9, right? 6 means this must be 16, and the only possibility is 7. Okay. uh, 1, 1. We know that both 1 and 2 is here, right? We have figured that out, isn't it? Because even if 2 is not there, this will be 1, 3, 4, 5, 6, 21. Yeah, this will be 19 if 2 is not there. That's not possible. So now 2 cannot be here. 2 is not here. 2 must be here. Mm. Again, 1 is not here, right? 1, this must also have 18 must have 1, right? Because if 1 is not there, this must sum to 20. So that's not possible. So 1 is not here. 1 is not here. This must sum to 1. I mean, 1 must be here. Now 1 must be here, right? Just by Sudoku. Um, now this one, right? How can this be 9 now? Because if this is 9, the remaining will be 3. The only possibility is 1, 2. But because of 1, that's not possible. So that cannot be 9. That has to be 4. That has to be 9. 4 now, this remaining must be 8. Uh, 1, 7 is out of question. So 2, 6 and 3, 5. That's 1. So if that could have been 2, we could have reduced something, but that's not possible now. Okay. That 9 now looks at here. So that's 7. That's 9. That 7 is looking at this, removing 7 from here. Uh, so 9 is one of this, isn't it? Just by Sudoku now. No, in fact, we have to ask where is 9 in this column. It's not here. That has to be 9. So 9 is 9. And now we know that 24 do not have 9. No, it must have 8. It must have. In fact, by Sudoku, where is 8 in this column? 8 cannot be here. 8 cannot be here. But look, 8 is here, right? So it cannot be here. So that has to be 8. So now this 24 has 8. The remaining digits must sum to 24 minus 8, 16. So if this is 6, 7, this will be 3 over there. No, that can't be 3 because 3, 6 is already looking at it. This must sum to 16. I'm just thinking if 5 is not there, so this will be 6, 7, which is 13, and we need 16. So that will become 3, which is not possible. So 5 has to be here, right? One of this has to be 5. No, I'm not sure about that matter. Maybe if I go other way, right? If 7 is there, let's say, out of 16, I will remove 7, right? 7 will be here. Uh, yeah, 7 cannot be here, right? So if 7 is there in this, it must be here because of this 7. So if 7 is there, 8 and 7, 15, this must come to 9. That's 4, 5 possible. I mean, that's 3, 6 not possible, 5 and 4 will be possible. And maybe do some Sudoku more and then come back there. Now that we got 8 here, we know 8 is one of these, right? So now 8 is not here, right? Because see, this is now x wing of 8. X wing of 8 means in these two rows, both the positions of 8 is either here or here, right? So 8 cannot be here. So 8 is here, but both 8 and 8 are here. So that means that has to be 8. And now 18 is without 8, right? That cannot be it, that cannot be it. It's without 7 also, right? So all 7, 8, 9 is gone from 18. So is it possible without 6? No, it's not possible without 6, because without 6, then this is 1, 2, 3, 4, 5, which is 15. So 6 has to be here. And 6, if has to be here, that is not 6. And if 6 has to be here now, this must be 4, isn't it? 1, 2 is there. So 1, 2 is there, 6 is there, that itself is 9. The raised 2 must be 9, which has to be 4, 5. So this is 1, 2, 4, 5, 6, right? That's the only possibility. 1, 2, 4, 5, 6. 3 is not there. Because with 6 and 1, 2, this sums to 9. The rest 2 digits must sum to 9. And the only possibility with 1, 2, 6 or 1 is 4, 5. So now that's not, so let's remove all the ones from here. None of that's 1. Let's remove all the 2 from here. That's not 2. That's not 2. We can remove 6 from here. We can remove 5 from here. And that's it, I guess. Yeah, unfortunately, that's it. 3, 6, 3, 6, right? We can remove 6 from here also. So I can say 6 is here, right? Because we must have 6 here. Where is that 6? Because of 3, 6, it cannot be here. Because of these 6 cannot be here. This must be 6. But that gives us 3 here. That gives us 6 here. That gives us 3 here. That gives us 6 here. Now this is single digit, right? In this column, 1, 2, 3. And 3 in corner, maybe we are on the right path. These 3 digits are right. 1, 2, 4, 5. Out of which that's not 2. 2, 4, 5. That's also not 2. 4, 5, 4. So that's 2. 4, 5, 4, 5. We need 3 digits here. In fact, we need 1 digit here. Let's put that, which is 1, 2, 3, 4, 5, 6, 7, 8. These 2 digits is 3, 7. Yeah, but 3 is looking at it. So that's 7, that's 3. These 2 digits, right? 1 is somewhere there, right? So that's 1. And the other is 6. That has to be, no, not 6. Sorry, my bad. 1, 2, 3, 4, 5. The other has to be 5. 1 is looking at this, right? And one of these is, so that's 1. That's not 1. That's 2, 3. All ones must have been done, except here. This x wing of 1. Okay. What about 2? 2 is remaining. 2 is one of these two. And in this, 2 could be here or here. Okay. Uh, Now what is remaining? Let's just put all these numbers and then do some solve. And then we'll do this sum. Uh, that's 7, right? If looking at this, so that's 9. That's 7. That 9 gives 8 here. That gives 9 here. This could have done way earlier in our puzzle. 4, 5, 4, 5. That's not single digit, which has to be now 3. Uh, 2, 9 is remaining. Is that correct? Oh, 3 gives 2 here. Let's do that simply. That gives 3 here. Yeah, now that's not 2, right? So these are 4, 9. Can I say that's 4, 9? 4, 9, right? In fact, that 9 gives 4 here. That will give 9 here. And with that, now can we get these two digits? Because we have this sum, right? Which is 8 plus 4, 12 plus 9, 21. So this must be 11. This must be 5, 6. There is no other way. Because 4, 7 is not possible. 2, 9 is not possible. 3, 8 not possible. So we got these cases 5, 6. 6 is looking at this, right? 6 is looking at this. So that's 5. That's 6. 5, 6. This must be 7. 3 is looking at that. That's 2. Um, that's 7. Remove 7 from here. These two digits we over these two remove 2 from here, giving 3 us. These two digits now we must have, right, from this column. This column, which is 1, 2, 3, 4, and 8, right? 8 is here, so that's 4, and that's 8. That 4 gives 2 here. Removes 4 from here. We can remove 2 from here. And we can remove we can remove 2 from here, and that means we have to remove 6 from here. This must come to 8. Let's remove all these pencil marks, because 1, 4, 1, 4, 1, 4, 5, 6, 1, 4, 5, 6, 4, 5. Yep, it's not okay. 6 is one of these. That's what we know. Yeah. Okay. So yeah, that's not 3. So that's not 5. 3, 6, 2, 5. These 3 digits, right? 1. Oh, this single digit maybe. 1, 2, 3, 4, 5, 6. That has to be 7 now. These 2 digits now. 1, 2, and 4, isn't it? 2 and 4. That 4 gives 2 here. That gives 4 here. Now this must be easy, right? 8 plus 4, 12. 12 plus 7, 19. So this must be 5 to get the 24 properly. Let us do some other way. 7 plus 4, 11 plus 8, 19. Yeah, that has to be 5. That's 6. Yeah, that gives 3 here. That gives 5 here. That gives 4 here. That gives 1 here. That removes that gives 6 here, right? 1, 4, 5. That's 6. That's 5. That 1 gives 4 here. That gives 1 here. That something should give something here. That 5 gives 4 here. That gives 5 here. That 4 gives this 5 gives 4 here. And that 4 gives 5 here. And now only these two digits, which are 1, 2 somewhere, has to be here, and the remaining is 6, which has to be here, and that's how. Okay, solution is not given. So so let's just do this correction, right? And maybe we know that the solution is there. You can't do that, right? Yeah, solution is not given. But anyway, 51 people has created in 44.7 days. That's not that high, right? Let's just do the sum. So this 19 we have seen, right? 7 plus 5, 12. 12 plus 8, 20. 20 plus 4, 24. This one is 10. 10 plus 14. 24 plus 8, 32. This we have seen, right? 7 plus 1, 8 plus 4. This was the smallest digit, right? Which is 12. This one, 8 plus 5, 13. This one, 5 plus 3, 4 plus 3, 7 plus 5, 12. This is 7, 9, 6. 9 plus 1, 15, 15, 16. 16 plus 6, 22. This 1, 2, 3, 6. 3, 6 is 9. 9 plus 3, 12. This is 9 plus 9, 18. This is 1, 4, 5, 10, 10, 9, 9, 9, 10. The remaining is what? This 18, right? Which is 6 plus 4, 10, and 5 to 1, 18, right? So I think this is a correct solution. The break-in was this set theory, right? So yeah, this is also my first set theory puzzle, I think, on this channel using this mathematics. Yeah, so I think that was great. So that's how you have to use the set theory properly. These two boxes helps here, right? Which is the 56 and this is the 30. Yeah. So yeah, that's it, guys. That's it from my side for today. If you have solved this using without set theory or maybe using some other sets, let me know, and uh, that will be really helpful. So yeah, thank you all, and we'll meet again.